Hello, everyone, and welcome to this session. Joining us today is Heimberg, who will give us insights about the implementation of data mesh for Engelbert Strauss, a well-known German brand manufacturer for workwear and protective clothing. Hi, Lukas.
Hi, Anna, and thank you very much for the invitation.
You're welcome. Thanks for being here. So let's jump right in. Like many big companies, Engelbert Strauss relies on an ecosystem of custom software to drive its business. So from logistics over customer relations to webshop, for instance. And over the past years, the company has gone through an agile transition. Could you describe this transition process a little bit for us?
In the past, the operational systems of Engelbert Strauss were quite monolithic. The development teams were far away from the departments that were responsible for logistics, customer relations, marketing, and so on. This slowed down the implementation of new features, and misunderstandings between development teams and departments could happen easily. To improve agility and quality of development, the operational system and its development teams were reorganized following the ideas of domain-driven design. Each department got a so-called squad, a domain-oriented and cross-functional decentralized development team. Every squad has a shared language with its department about business logic and a clear ownership for the operational systems that implement the business logic of the department.
So, of course, Engelbert Strauss, like most companies, uses analytical data about its business processes to inform decision-making, to optimize processes, and so on. So how did this agile transition change or apply to the handling of analytical data?
Historically, analytical data at Engelbert Strauss was mostly used for a relatively static reporting. For this purpose, there were a few centralized data warehouses that were managed by equally centralized data warehouse teams. These data warehouses were fed by ETL pipelines, extracting data from the operational systems across all departments.
So it seems that there might be a conflict between the decentralization applied already to the operational processes and, on the other hand, still centralized data warehouses. Did this lead to any problems?
Absolutely. It led to the typical problems of centralized data warehouses. The ETL pipelines into operational systems turned out to be brittle. They depended on details of the operational systems and the evolution of the operational systems over time. To keep up with the operational systems got harder and harder for data warehouse teams that were not embedded into the development of the operational systems. Not only did ETL pipelines fail sometimes, but also the meaning of the data extracted from operational systems, how it can be used properly for analytics, and which limitations it has, got sometimes unclear. And this problem only got bigger as the semantics and quality of data also needed to be made accessible to the users of the data warehouses and finally to the audience of the reports. Another closely related challenge is that there has been a growing interest on analytical data at Engelbert Strauss that goes beyond the classical reporting. BI analysts want to use self-service BI with tools like Tableau autonomously. And there are use cases for machine learning, for AI, and for near real-time event processing that can hardly be supported by classical data warehouses.
Mm-hmm. And what were the root causes of these problems?
The root cause of these problems that led to a loss of agility and data quality and finally hindered the development of a data-driven organization was a mismatch in the ownership of analytical data. Whereas the domain-driven transition of the recent years aligned the software development with the domain knowledge, the analytical data remained under the ownership of data warehousing experts instead of the people that best understand its origin or use cases.
So how did you tackle these problems?
In 2019, the so-called data mesh architecture got introduced by Jean-Marc Dechany. In a nutshell, the data mesh architecture applies ideas of domain-driven design to analytical data with the aim of a decentralized data platform where analytical data is owned and actively shared by the most suitable domain. After the Agile transition at Engelbert Strauss, the data mesh architecture appeared as a logical choice for the organization of analytical data as well.
Mm-hmm. So could you describe the basic concepts behind the data mesh architecture?
Sure. The data mesh architecture is based on 4 interlinked principles: domain ownership, data as a product, a self-serve data platform, and federated computational governance. Domain ownership means that analytical data is not owned by some central data platform team. Instead, it stays under the ownership of the domains that determine its meaning and life cycle and that know the best about its quality. This could be, for example, the domain from whose operational systems the analytical data is derived, but it could also be a domain that has a specific use case for the analytical data. In both cases, the analytical data is managed by the same cross-functional domain development teams as the operational systems. The principle of data as a product means that analytical data is not a passive byproduct of the operational systems, but that it is rather shared intentionally and designed with consumers in mind. A data product is an API for analytical data whose form is negotiated with consumers and evolves with their needs. It is discoverable, understandable, and usable autonomously. Intended for long-term use, it is also versioned and keeps certain SLAs that are agreed upon. The self-serve data platform is not only used for finding and consuming of analytical data, but also for the development, deployment, and monitoring of data products in a way that conforms to the rules of governance and that is also feasible for domain development teams that do not have a strong data engineering background.
Mm-hmm. And could you elaborate a bit more on the aspect of governance when it comes to data mesh?
On the one hand, governance, of course, needs to prevent analytical data from being abused, for example, by establishing rules about access control and by applying regulatory concerns to the analytical data. One important example is the GDPR that ensures the authority of individuals over their personally identifiable informations through methods like pseudonymization and the right to be forgotten. On the other hand, however, governance also needs to ensure that analytical data is discoverable, that it is understandable and usable for different use cases across domain boundaries. It encourages network effects and ensures that the data mesh is actually more valuable than the sum of its parts. Federated computational governance is data governance in a decentralized data platform of largely autonomous owners of analytical data. It takes into account that knowledge about analytical data and its use cases is spread over domains. For this, a high degree of automation and standardization is needed, and a fine balance between global concerns and the autonomy and local decision-making in domains that is needed to ensure agility and scalability.
So we've heard about some pretty abstract principles now. So how would you go about actually implementing a data mesh?
It's true, these principles are indeed very high level and technology agnostic, but for a good reason, because it's important to understand that a data mesh is not a ready-made technology. Data mesh is primarily an organizational change in the ownership and responsibilities for analytical data. However, this organizational change is implemented as a decentralized way to use data technologies that is supported by platform engineering. It requires a careful design of APIs that abstract the use of the underlying technologies and that allows the standardized development and use of data products by generalist developers.
So it is safe to say that an actual implementation and data mesh solution is pretty specific to a given organization.
Absolutely. Yeah. The choice of technologies for storage and transformation of analytical data depends a lot on the organization and its primary use cases for analytical data. Often, technologies that are already used can be reused so that already existing integration and experience helps the development of the data platform. This is in particular important as Implementing a data mesh, including all the organizational changes it comes with, is a big undertaking that requires an agile and step-by-step approach. Another question is the design of the self-serve data platform APIs. Domain development teams are expected to develop, deploy, and maintain data products besides their operational systems. You need a good understanding of the workflow and the CI/CD pipelines of the domain development teams to ensure that the APIs of the self-serve data platform are designed so that they are familiar to use for them and that they integrate into their workflows and into the life cycle of their operational systems.
Mm-hmm. So I think this is a good moment to look again at the data mesh solution for Engelbert Strauss. Could you describe the situation that informed your design choices when building this particular data mesh solution?
Sure. As already mentioned, each department of Engelbert Strauss has its own development team called a squad. Mm-hmm. Squads develop and deploy decoupled microservices on their own Kubernetes clusters using a GitOps approach. These Kubernetes clusters live in the private cloud of CID and are integrated by DevOps into central monitoring and logging solutions. Many of these microservices communicate asynchronously using event sourcing via Apache Kafka. DevOps manage an on-prem Kafka cluster that is shared among all squads for this purpose. As an early step towards decentralization, squads started to develop small special-purpose data warehouses called data marts on their own. For this, Snowflake, a public cloud OLAP database solution, is used. Similar to Kafka, there is one shared Snowflake instance that is managed by DevOps and used by all squads.
And what did this imply for the data mesh at Engelbert Strauss?
The preconditions at Engelbert Strauss in terms of technologies and workflows guided the design of the so-called infrastructure plane, as well as the developer experience plane of the data mesh. The infrastructure plane is comprised of the infrastructure to store and process analytical data, whereas in the developer experience plane, data products are developed, deployed, and monitored within the squads. For the infrastructure plane, we decided to initially focus on support for Apache Kafka and Snowflake. This covers the current use cases, including the decentralized data marts, and Apache Kafka also provides a bridge to the operational systems. This way, we could benefit from the experience of DevOps in squads, and the infrastructure was ready to use for us. Support for Apache Kafka and Snowflake has one important implication for the self-serve data platform. Data products, and even the components of a single data product, are distributed over a multi-cloud environment. Therefore, the APIs of the self-serve data platform need to be able to integrate components that live in different clouds. The design of the developer experience plane was guided by this requirement to support a multi-cloud environment for storage and processing of analytical data, but also by the Kubernetes-based development and deployment workflows within the squads. Developers interact with the self-serve data platform using Kubernetes API extensions within their Kubernetes clusters. Take storage as an example. Kafka topics or Snowflake databases are provisioned using custom resources that are managed by Kubernetes operators. Data products are then developed as so-called Helm charts, that is, packages of Kubernetes resources that may be comprised of resources to allocate storage, as well as built-in Kubernetes resources and other API extensions. The benefits of this approach are an easy-to-use and declarative API for data products that is extensible and that can make use of everything Kubernetes has to offer.
Mm-hmm. And so how can data products be found and also connected to each other?
To make data products discoverable and to allow them to connect to each other, and also to ensure global standards of governance, there is a third plane called the Mesh Supervision plane. The Mesh Supervision plane keeps a central registry of data products across all departments. Further Kubernetes API extensions in the developer experience plane are used to equip each data product with metadata that is automatically registered in the mesh supervision plane. This registry is then used in two ways. On the one hand, it updates a data catalog. This data catalog allows to search for suitable data products and visualize their relationships. Developers and also BI analysts look into this data catalog to find analytical data that supports their use case across all departments. On the other hand, the registry is also used to actually connect data products to each other. Kubernetes API extensions in the developer experience plane allow to reference upstream data products from downstream consumers. They make sure that access privileges are validated. Access is granted with the means of the underlying technology, for example, right now Kafka or Snowflake, and they inject connection information into the consuming data product. And this connection information can then be used with arbitrary suitable frameworks within the data product.
Mm-hmm. So I take it there is no central data access layer, like for instance Presto or something like this?
Indeed. Access control and data exchange is pushed down to the individual technologies like Kafka or Snowflake. This way, we can benefit from the perks of these technologies, for example, scalability, and we also reduce data transfer between clouds. However, if needed in the future, a central data access layer can be added and just treated as another storage technology.
I see. What are the key takeaways from the implementation of a data mesh at Engelbert Strauss for you?
Altogether, our careful analysis of the situation at Engelbert Strauss in terms of organization, workflows, and technologies led to a very scalable and extensible decentralized data platform that increased the agility in handling analytical data and improved its availability and quality. The data platform itself is in a continuous agile development and open for new use cases and their needs. It turned out to be a good idea to first focus on the infrastructure layer and the Kubernetes API extensions that integrate into the developer experience plane. This relieved DevOps and gave autonomy and an integrated lifecycle management back to the squads, even before the mesh supervision plane itself was ready. This way, we got early adopters and were able to create trust in the platform.
Mm-hmm. And what would you recommend to an organization that wants to start out, that wants to use data mesh and starts from scratch?
It is important to be aware of the impact of the change of ownership and responsibilities for analytical data. There might be worries about losing control in some, and in the decentralized development teams, there might be worries about the additional workload and the required skills. This needs to be addressed by a clear commitment from the management to the data mesh approach, and in particular, a prioritization of data products as first-class citizens of software development. Knowledge transfer to the domain development teams is also essential, and in particular in the beginning, a close company to ensure that the growing self-serve data platform is used in the right way. As the implementation of the data mesh is a long-term project, it is also important to start agile and strategically with platform features that solve existing problems and that point into the right direction. Furthermore, it is important to identify early adopters with the right skills and whose use cases provide a clear value and fit well by the structure of the data and the integration needed with operational systems. However, after choosing and supporting the first use cases, be also aware of the bias they might have introduced into the overall structure of the data mesh. Does it maybe consist of a set of largely disconnected special purpose data products? And are the central sets of analytical data that are typically used for decision-making in your organization well represented? It is very important to monitor the development of the data mesh as a whole.
Do you also have recommendations when it comes to technologies chosen?
From a more technical side, evaluate the technologies for storing and processing of analytical data you already might have. See if, as a first step, they can be reused in a decentralized way to benefit from experience and already existing integrations. However, Keep in mind that analytical workloads are typically very different to operational ones and that operational systems shouldn't be impacted. If you decide to add new data technologies to your stack, check whether their APIs lend themselves to integration into the self-serve data platform. For the self-serve data platform itself, it is important to find a solution that does not only prioritize the discovery and use of data products, but also their development, deployment, and monitoring by generalist developers. For this, good development practices and the domain development teams are crucial, and good understanding of the domain development work teams' workflows and tooling. And don't underestimate the involved API design, platform engineering. A data mesh implementation requires experience with technologies for analytical data, but also with platform engineering. And it also requires best practices and governance to ensure that analytical data is protected from misuse, in particular that the rights of the individual in regards to its personal information are respected, but also that analytical data is designed for the largest gain. And last but not least, it requires a deep understanding of the organization in its social and technical aspects and needs.
Thank you. So before we conclude, do you have any closing words, anything you would like to add?
If you are already on a path towards agile development and decentralization in your organization, the data mesh approach will help you to streamline ownership of operational systems and analytical data, and improve agility as well as availability and quality of analytical data. It can be a very important step towards a data-driven organization. If you are curious, let's have a call and see how your data mesh could look like.
Thank you very much, Lukas.
Thank you very much, Anna.
And thank you for watching. Please also check out the CID website, because Lukas has a blog post on data mesh ready for you there, in case you would like to read up on some of the stuff that we've talked about today. Thanks again, and bye-bye.